So in our last lecture, we walked through how to actually calculate an F statistic. We also found out that there is an F table similar to a Z and a T, where you would then compare your cutoff to the actual F statistic that you actually computed. The overall analysis of variance F that we produced is called an omnibus F. That's very important. Omnibus is the overall F. This test tells us that yes, our groups differ, but it does not tell us specifically which groups differ from each other. It only tells us that some means are statistically significantly different. So if we want to find out which groups actually differ from each other, we have to do what's called planned comparisons. Planned comparisons are the subsets of all possible comparisons. And with the planned comparisons, the researcher decides at the beginning of the research that they are going to do all of these possible pairings to see which groups actually differ statistically from each other. Now, if you don't want to make that determination at the onset, you can do what's called post hoc test. And we'll talk about post hoc test in our next video. But let's continue with planned comparisons. With a planned comparison, you actually do the same steps that we did previously to compute an F, but this time you only use 2 tests at a time. Now notice this is going to end up changing your overall degrees of freedom, and it's going to change your overall number of groups that you are using. So when you walk through the formula, you're going to do it the same way. You're going to figure it the same way, except for now, you're only using 2 means at a time. So we would compare 8 and 4, we would compare 4 and 5, and then we would go back and compare 8 and 5. And we would take the F statistic that's computed for each one of those, and we would compare it to our cutoff F that we look up in our book in the F table. So, again, you would estimate the variance of the distribution of the means the same way we did before. You would estimate the variance for the population of the individual scores the same way we did before. You find the degrees of freedom for between and within, and you find the cutoff and you compare it. Now the problem with doing multiple analyses like that over and over and over again and computing lots and lots of F statistics simply means that by chance alone, some of them are going to come up statistically significant. And they're really not going to be. In other words, we're going to end up making a type 2 error. So if we want to reduce the likelihood of us making a type 2 error, what we need to do is actually decrease the alpha level somehow. We talked about this in a previous chapter. So one of the ways that we want to actually do that is we want to use a procedure called the Bonferroni or Dunn's test. With a Dunn's test or a Bonferroni procedure, you're actually just making the cutoff more stringent, and it makes it that much more difficult to find statistical significance. But as we said before, if you find it, you can be assured that it's probably really there. So what you do with the Bonferroni procedure is you actually take your overall statistical significance that you compute with your 2 means, and you divide it by the number of planned comparisons that you want to do. You use the resulting significance level for each comparison of a pair of means. So let's say that we're going to do 5 planned comparisons. As I said, if we do them all at the 0.05 level, it's really not at the 0.05 level, it's really at the 0.25 level, because we increase it every time we do one. So if we find statistical significance, it's really at the 0.25 level. If we use the Bonferroni, we take our 0.05 level, our alpha level, we divide it by 5, the number of planned comparisons we want to do, and now our alpha level is really at 0.01. So that means any statistical significance we come up with, comparing our two means, we are looking at it and comparing it at the 0.01 alpha level instead of the 0.05. Next, we're going to talk about post hoc test. Come back.